Hello to you all. Good morning, good afternoon, good evening, everyone. It's a pleasure to see so many of you joining us today, united by our shared passion for quantum science and technology. My name is Dr. Etiabia Ado, and I have the honor of serving as your MC for this exciting event, which is the e-learning African International School on Quantum Science and Technology. I am part of the organizing committee and I'm deeply committed to advancing quantum science and technology, particularly for us here in Africa. I have been in this field for the past 3 years, working in the area of variational quantum algorithm, and I've had the privilege of witnessing firsthand the incredible potential that quantum science and technology hold for our transforming world as Africans. I'm excited to be part of this journey with all of you, and I look forward for exciting moments, exchanging ideas, and explore the ways that quantum computing can help advance Africa. I'll be guiding you through today's sessions, ensuring that we stay on track, that everyone has the opportunity to engage fully in this experience. Let's make the most of this opportunity to learn and collaborate and inspire each other. Once again, welcome to our opening ceremony. Let's get started with an opening prayer by our brother Henry Kwesi.
Okay, thank you, doctors. So I am Henry Kwashi, and also I'm part of the team. So for us to begin today's program, let's bow down our heads for prayer. Heavenly Father, we thank you for today, and we thank you for how far you brought us. As we gather here today as a community of scholars, researchers, and learners, eager to explore the world of quantum science and technology, we thank you for the gift of the knowledge and the curiosity that drives us to discover and innovate. As we embark on this journey together, we ask for your guidance and wisdom. May our minds be open to new ideas, our hearts be filled with collaboration and respect.
Thank you so much, Henry. As we get started and we are on pause, we would like you to tell us wherever you are joining us from in the pool. If you don't mind, just let us know wherever you are joining us from. Thank you so much. In our excitement to interact and in a superposition state, we would like to take the welcome address from Professor Akwesi Echampon Eni.
Good afternoon. I am Akwesi Echampon, and on behalf of the head of the department, so wasn't able to make it. Chairman, Provost College of Science, KNUST, e-learning director, our cherished facilitators, organizers, dear registered students and professionals, ladies and gentlemen, good afternoon once again. The Department of Physics, KNUST, focuses on a list of research areas in material science, nuclear science and technology, geophysics, and mathematical and computational physics. And it is the mathematical and computational physics unit of the Department of Physics at KNUST, which in collaboration with the KNUST e-learning center is organizing this e-learning African International School on quantum science and technology on the theme harnessing quantum science and technology for innovation and development in Africa. And this is in line with the university mandate. And the MC, the Mathematical and Computational Physics Unit, the university is and the department very grateful for that. As we are all aware, next year is the International Year of Quantum Science and Technology. And these activities are part of the preparations towards the year of quantum physics. And I believe that this 6 months program from August through to February next year, which has a lot of interesting topics, not limited to quantum computing, simulation, machine learning, the application, and quantum in chemistry, and the rest, will be an interesting one. And I would like to take this opportunity to also thank the organizers very, very much for putting this together. And I know that our dear students and professionals who have registered will have an exciting time for this 6 months period. Once again, I welcome you all and I wish you very exciting 6 months. Thank you.
Thank you so much once again, Prof. Enin, for a wonderful welcome address. Let's all embrace ourselves for the uncertainty that lies ahead of us in this quantum world and make an impact. We are very privileged and honored to have a chair for this honorable occasion, and he is in the person of Professor Leonard Amefuji, the current provost of College of Science, KNUST, a very renowned researcher and a very experienced man as well. He has a background in physics and also in atmospheric physics and satellite remote sensing from the University of Bremen, Germany. He has over 18 years of research experience. He has been involved in numerous international projects and has also served as a research fellow at ICTP as well. His research interest covers atmospheric and climate science, remote sensing, biometeorology and precipitation processes, hydrological modeling, climate change adaptation, and a lot more. We are so privileged and honored to have you, Prof, with us to share this wonderful future for quantum science and technology for Africa and especially for us in Ghana here. Prof Chair, your audience. Audience, please, our chairperson for today. Thank you.
Okay, thank you very much. And it's very exciting for us to have this workshop. And my text shows that we have about 122 participants online that made up of the technical team, including the experts that are going to give the lectures, and then also student or learner participants. You are all welcome. And as someone who has my foundation from theoretical or mathematical physics, I'm very excited that we are having this workshop. The workshop that will introduce participants to quantum materials, including quantum computing, machine learning, is very important in the modern time that we find ourselves. And therefore, I'm excited and happy to be the chairperson for this workshop. Thank you very much.
Thank you very much, Prof. At this juncture, we'll move on to the next speaker on the line. And we would like to talk about our guest speaker, who is in the person of Professor Abba Bentil Andam. Of Abba Andam, who is one of the renowned scientists and physicists in Ghana. So, Prof. Abba Bentil Andam is a consultant physicist specializing in environmental radon monitoring. She is a fellow of UK Institute of Physics, the Ghana Institute of Physics, and the Ghana Academy of Arts and Sciences, where she previously served as the president. She is a member of IPA Commission on Physics and Development, C13, and foundation member of IPA Working Group on Women in Physics. She has held significant roles at KNUST and as one of the head of Department of Physics, SNACS, and has contributed global significant scientific initiatives, including serving on UNESCO Advisory Committee and currently steering committee for the International Year of Quantum Science and Technology 2025. Her research interest: environmental radon monitoring, investigating radon levels in various environments, and the implication for health and safety. Thank you, Madam Professor. Thank you for joining us. So we'll hear from our guest speaker at this juncture.
Distinguished ladies and gentlemen, I thank the organizers of this program for inviting me to give the keynote address. Today marks a significant milestone, not just for the Kwame Nkrumah University of Science and Technology, which is hosting this program, but for the entire African continent. New doors are being opened, new frontiers are being explored, and future technology in ways that were once unimaginable are being started. Quantum science and technology represent the next great leap in human innovation. While classical computing and technologies have driven much of the progress we've seen over the past few decades, quantum technology holds the promise to revolutionize industries, economies, and societies on a global scale. From secure communications through quantum cryptography to potential for unprecedented computational power, the possibilities are as vast as they are exciting. However, we must also acknowledge some concerning trends. That there have been a noticeable decline in the number of students pursuing physics, both at secondary and tertiary levels. This decline, distinguished ladies and gentlemen, is troubling because physics is not just any odd subject. Physics is the bedrock of scientific understanding and technological advancement. With a strong foundation in physics, we can be sure that the dream of harnessing quantum science and technology for African development will be realized. Physics education must be revitalized for both men as well as ladies. This requires modernizing the curricula, improving teaching methods, and providing students with the tools and support they need to succeed. In addition, we need to emphasize the inclusion of men as well as ladies studying physics. Despite various efforts, we see that some people still see physics as a subject that is so daunting, it must not be approached and only be studied as a tool for other disciplines. We are indeed depriving ourselves of the diverse perspectives and innovative ideas that all categories of people bring to the table, and we need to get a study of African at all levels in quantum science and technology. While the continent faces challenges such as infrastructure development, healthcare, and education, it is also a land of untapped potential and remarkable resilience. Quantum science and technology offer our continent the opportunity to leapfrog traditional development paths and address some of these challenges in innovative ways, such as solving complex problems, advancing healthcare, driving innovation in industry, empowering education and research. As we launch this program, we are not just educating the next generation of quantum scientists and engineers, we are improving a new wave of African innovators who will contribute to global knowledge whilst addressing local challenges. This school will serve as a beacon of knowledge, bringing together some of the brightest minds on the continent and from around the world. Africa must not be a mere consumer of quantum technologies, but an active participant in the development of quantum science and technology. To truly harness the power of quantum technology, we must also focus on building the necessary infrastructure. This includes state-of-the-art research laboratories, quantum data centers, and innovation hubs that will serve as the backbone of Africa's quantum revolution. Collaborations with global institutions, the development of quantum hubs, the nurturing of talent are all essential steps in this direction. As we advance in quantum technology, we must remain vigilant about the ethical implications, from data security and privacy to ensuring that the benefits of quantum advancements reach all segments of society. Our approach must be both inclusive and responsive. Our collective responsibility is to ensure that the benefits of quantum science and technology are accessible to all. This requires a concerted effort from governments, academia, industry, and the broader society. We must build the necessary infrastructure, provide the right education, and foster an environment where innovation can thrive. Additionally, we must look tirelessly to reverse the decline in physics education and actively support both men and the women in their pursuit of scientific careers. As we stand on the cusp of a new era, we remember that the future is not just something that happens to us at random. The future is something we purposely create. The role of quantum science and technology in Africa is not just about adopting new tools, it is about reshaping our destiny. It is about using the power of quantum wealth to build a future that is prosperous, equitable, and sustainable for us. We embrace this opportunity with enthusiasm, dedication, and a shared vision of what we can achieve together. I am confident that the e-learning Africa International School on Quantum Science and Technology and the projects yet to be taken will be a catalyst for change, sparking innovation and collaboration that will resonate far beyond these virtual walls. I thank you for your attention, and I wish the learning process and you, the good people participating in it, every success. Thank you.
Thank you so much, Prof. That was a wonderful speech. Just as quantum particles exist in a state of superposition where they can be in a multiple states at once, today you and I find ourselves in the intersection of learning, innovation, and collaboration. Let's embrace this unique opportunity to explore all possibilities together. Once again, Prof, thank you so much. And we would like to once again welcome all of you, our participants, our facilitators, mentors, researchers from all over Africa and worldwide. We appreciate your presence so much for joining us. In respect to that, we would like you to share your experience with us. What comes to mind when you hear quantum science and technology? So we are sending a link in the chat. Kindly click on that link and just in one word, share your experience with us. Just in one word, or your thoughts. What comes to mind? So we have the link in the chat now. Please, let's do that using the link, not in the chat. If you have a question, you can use the chat room to ask your question or by using the reaction raise hand to also ask a question. So you raise your hand and you'll be asked to unmute yourself and ask your question, please. We are still waiting on your responses. Wow. So, wow. It says dice, imaginary, entanglements, innovation, confusing. Interesting. Yeah, so in this confused state, in this uncertainty, what we don't even know what holds for the future, I think we can engage in wonder technology. In this uncertainty, there can be a breakthrough as well. In this uncertainty, we can get together to develop new tech as well. Wonderful submission. Yeah, so that is great. So we move on. Let's get to entangle. Let's get to mingle without any interference as well. I think more are trying to get their one word. Wow. Oh, I see weird. What am I seeing? Just there. Okay. So advancements. Wow, probability theory, a whole lot. So quantum has a lot, and you realize that it just cuts across with whatever comes to mind. You are just thinking about the next generation, yes, for which you are here. Okay, thank you so much for sharing your thoughts with us on what quantum is to you. As we delve deeper and deeper, into the world of quantum science and technology, I believe that these innovative ideas, the skill of problem solving, all our uncertainty will all come to one point and impact wherever we are. Thank you so much. Thank you, thank you, thank you for the reason you are here to for the e-learning International Quantum Science and Technology for Africans. We would like to invite the e-learning director, the brain behind the whole e-learning quantum science and technology, in the person of Professor Apel Asante, to give us a talk on the e-learning resources for the school. So he is an associate professor of educational innovations at KNUST, the director of e-learning as well. He's a 2023 Star Ambassador for the Association of Commonwealth University and leads a partnership for enhanced and blended learning at KNUST. On this note, you are not lost at all. He has a master's in educational leadership from the University of Education, Winneba, and additional certifications in instructional design and online learning. He has received the Getty Foundation Scholars Award and the CEDAR Named Award for supporting technology-enhanced learning. His research interest lies in curriculum studies and development, foundations of education, differentiated learning and instruction, learning and multimedia development, inclusive education, and school-based inquiry blended learning and educational technology. We are very honored to have Prof. Eric Apel Asante with us to take us through the e-learning resources in KNUST. Thank you so much, Prof. Your audience.
Thank you so very much, my dear, for the introduction. It is just going to be very brief. And I'm so excited that this whole idea of quantum school is seeing the light of day. And I want to, on behalf of the management of the e-learning center that works directly under the office of the Vice Chancellor, congratulate all those who have been enlisted on this program and say that, yes, you made the best of decisions to get enrolled on this. You wouldn't have gone for any other thing. That probably presents you with prospects to buy into best practices in today's global world than this. We appreciate your interest in this, and they will congratulate you. And also to assure you that whilst you're on this program, the KNUST e-learning center as a partner to implementing this agenda is so positive and poised to support you with all the resources that are available to get this thing done. You can leverage on the various e-learning resources and technologies that the university have to support online learning, the digital structures that we have in place to support your digital education. And then also, most importantly, whilst you stay on this program or course, for flexible learning and for innovative learning, we believe that all the resources that we have should be able to help you. Probably just to give you specifics, as you would have witnessed, and pretty soon in this orientation you'll be told, the University e-learning center leans on a very strong learning management system, which is serving our university community very well, and even our affiliates. And for that matter, we can say with confidence that as a widely used learning management system, that we work with, we can use that also to facilitate this course. In terms of its content delivery, for facilitators who will be doing the delivery remotely, even for assessment, when you have to be taking quizzes and assessment in different modes, and for communication between you and your instructors. So our learning management system, virtual classroom, will certainly serve this purpose. We've also been working very well, serving the over 90,000 student population and our affiliates with our virtual classroom and video conferencing resources, one of which you have been hosted on today. And so we can be fully assured of stable and quality recorded live lectures and webinars and interactive sections with features that will enable breakout rooms and features that will help us to pick polls like what you have just done today, and has recording capabilities so that all our recordings are in place and you are able to access it in case any erratic dropouts is encountered. You can always get back to them and work with it. We have interactive content creation tools that we believe you will be able to work with. And such interactive resources would be able to also support your delivery here. For your information, KNUST runs online computer-based examination. And so for this school, be rest assured that with our systems in place, we should be able to deploy all these resources as well to support you. Whilst the other good news is our open educational resources that are available, which you can leverage on. I'm talking of the digital libraries and open educational resources. So the KNUST Digital Repository, which is a platform for assessing our research outputs and theses and dissertations and other academic publications, will certainly also be used to help. So many others are available. Just be rest assured that once you have made this decision to learn on this e-learning quantum school, the e-learning directorate of the KNUST, together with our collaborators, would release our strength to be able to achieve this result, which is so much needed. Stable support units, which would also consistently attend to the needs as and when it requires so. So ladies and gentlemen, without belaboring the points, I'm just here to assure you that the e-learning center has the resources you require whilst you stay on board to go throughout this whole school, which starts from now, and also with the resources that you may need to continue even beyond here. And therefore, at any given point in time, count on us that we are available to get you sorted out whilst you course. Once again, congratulations for getting enlisted, and have a very pleasant stay on the program. Thank you.
Thank you so much, Prof. I'm already excited because I have moved from the ground states already and I'm in the excited state. So I think for me, my energy is so high. I guess it's same for you and you're excited about this. And it's great to know that KNUST has all the resources to support us in this journey. Thank you once again, Prof. I would like to acknowledge the presence of other guests we have. We have Professor Marian Inkansa with us in the Department of Chemistry, KNUST. We have our honorable lecturers and professors from the Physics Department, KNUST. Professor Dr. Donko is here with us, Dr. Bavari, Prof. Enin, and we want to acknowledge your presence as well. And we have our partners as well from Germany. So Prof. Dieter is here. We'll hear from Prof. Dieter very soon. So kindly stay glued as we get to hear from them as well. So all our German group, the Continuum group as well, we want to appreciate your presence with us. Thank you so much. So, I mean, we are here for e-learning. We'll invite our brother, Dr. Henry Martin, to give us the overview of what this e-learning school is all about. Dr. Martin.
All right, thank you very much, Dorcas. Good afternoon, Mr. Chairman, the Provost of College of Science. With your kind permission, I would like to stand on the already protocols established. My name is Henry Martin, a faculty member of the Department of Physics, KNUST, specifically the Mathematical and Computational Physics unit. At this opening ceremony, I have a single honor of presenting an overview concerning initiative on quantum science and technology. This depicts the outline of my presentation. Quantum mechanics is the fundamental theory in physics that describes the behavior of matter and energy at the atomic and subatomic level, as known to us all during our junior and senior high school education. This we further got the knowledge of wave-particle duality, uncertainty principle, superposition, and among others. As said by the great scientist Sir Isaac Newton, and I quote, "If I have seen further, it is by standing on the shoulders of giants," unquote. We all here are standing on shoulders of Max Planck, who introduced the concept of energy emitted in discrete units called quanta, leading to Albert Einstein explaining the photoelectric effects as light consisting of particles called photons, through Edwin Schrödinger wave equation and Paul Dirac formulation of Dirac equation. Today, in these modern days, we all here have indeed seen further, as most leverage on the principles of quantum mechanics in creation, innovation, and developments. Developments such as semiconductors and transistors used in our phones, solar system, and others. The figure here depicts the sun ray that composed of photons that is inherent on the panel, which are forms of cells, of which the energy from the photons transfer to the electrons of the semiconductor material, causing movement of the electrons to create electric current in the cell. In addition, the medical fraternity, where scanners such as PET is used in visualizing images of human systems that reveals the metabolic and biochemical function of our organs, as we see in this figure. Quantum mechanics and quantum science and theory, which we have seen further, made this possible. Also, in the pharmaceutical industry or research institutes, drug discovery is done with the use of quantum simulations, such as molecular dynamics, to visualize and understand the capability of chemical reactions. Africa, as one people, a continent, needs to get involved in this revolution that will improve our declining education as we all are witnessing today. This will accelerate our technological development that channels more into our research industrial base solution output. This may improve our data security and optimize resource management, such as regional and district database of inhabitants. Also, our health database in our hospitals. This may come about with different softwares, devices, and others that can be developed and manufactured here in Africa, our continent. In all, it will stimulate the economic growth and the economy of the continent as a whole. This will allow Africa, as Africans, to be competitive in the global scale and participate in shaping the future of quantum technological landscape through transnational partnership, giving fundings and knowledge exchange. Ghana, to be specific, started this journey in 2021, where we joined One Quantum Africa and formed One Quantum Ghana. This I know our other collaborators and partners of One Quantum Africa have joined us here. With some of the participants are coming from other African countries as well. Ever since, we have had several educational and training activities as depicted in the flyer, and the reason for today's gathering with the opening ceremony of the e-learning African International School of Quantum Science and Technology. Well, this is not the start, but a continuation of greater and better things to come our way. Indeed, once again, here we have seen further, but more work needs to be done by all of us in the continent as Africans. Ghana is taking the lead in the way with what we call Ghana Quantum Education. The Ghana Quantum Education, this is to visit all senior high schools across the country, imbibing in them quantum science and technology, which needs the teachers for continuity and sustainability. Hence, we have the Ghana Training of Trainers. This Ghana Trainers of Trainers will also give onto the teachers of these senior high schools, improving upon their knowledge and understanding with better skills to imbibe more in our junior sisters and siblings in our senior high school. Well, as one people, it's necessary to come together and brainstorm for the future of quantum science and technology. This again, we propose African Quantum Conference next year to also commemorate the celebration of the International Year of Quantum Science and Technology as proclaimed by the United Nations. Again, for development and innovation, just as Prof. Madam said, it's very, very needed and important to set up infrastructures, quantum hub and quantum data centers for quantum industrial-based solution. All of this through the enormous hard work and dedication of this team so far. May I take the chance and opportunity to ask the audience to give them a thumb up icon for the work they have done so far as it deems well. So far, these are the collaborators that we have come with. Thank you, grazie mille. Truly, we have seen further, and indeed, we will see further. Thank you very much.
Thank you so much, Dr. Martin. That was a wonderful presentation, taking us through the basics, background, history, and their applications, which I think for us in Africa, we will benefit most. So like you said, more work needs to be done by all of us. So we are here today, facilitators, mentors, collaborators, and all our partners. We are saying more work needs to be done, and we need all the support that we can for this to go on. Thank you so much once again, Dr. Martin and thanks to the organizers and to the departments of Physics KNUST that is making sure that all these things happen in Ghana and extended to all countries in Africa. So in the spirit of superposition, where multiple outcomes coexist, I encourage each of you to explore the different ideas presented in this presentation, and let's see where they might lead us in our journey of discovery. Thank you. I'm so excited and overwhelmed already. I'd like to invite, one of our collaborators, the German collaboration we have, Professor Dieter Meschede. Prof, if you are here with us, I would like to invite you to extend your greetings and a word to the community. Prof is a prominent physicist and a professor for his significant contributions to quantum optics and atomic physics. He is a professor emeritus at the Institute of Applied Physics at the University of Bonn, where he has made substantial advancements in the field of laser cooling and trapping of atoms. Meschede's research has also explored quantum information processing and fundamental aspects of quantum mechanics. His research interests lies in quantum optics, laser cooling and trapping, quantum information processing, fundamental quantum mechanics as well. We are very excited to have Prof with us and for the future collaborations that holds for Ghana. Prof, please.
Okay, and I'm ready to say something. Can you hear me?
Yes, Prof.
Okay, very good. Well, it is my real pleasure to be here, and I thank Dorcas and Henry Martin, who I have met only maybe a few months ago for the first time in my life, to be able to speak here to you. And let me start by saying I'm very impressed by seeing so many young faces on the screen ahead of me. And so when you said I'm a professor emeritus, so I mean, one reason why we are celebrating this year of quantum science and technology next year is that because we believe that 1925 was kind of the most important starting date. It was really a decade when all this started, but 1925 really gave a number of breakthroughs. And so if you consider my age, roughly, to my own amazement, roughly half of that time, almost 50 years, I have participated in this research in physics now. Now, many of you are much younger, but one of my issues is that it is the young scientists who will have to carry this into the future. So the International Year of Quantum Science and Technology, this is what brought me in here and what brought us together, is an opportunity of bringing people together. Also, I have to say, beyond physics, because science is for all people and all times around the world. And we have to, I think our dream is that everybody participates in this and has a chance to participate and, well, very importantly also, to enjoy it. I hope you can enjoy the science. If it's a lot of burden for you to do science, it's very difficult. But if you enjoy it, it's really something very important. So, yeah, we have started to work together, I think, at the present time, we are preparing a little proposal or so. So I'm from Germany, and you introduced myself already. I'm from the University of Bonn. And we have a spring meeting on quantum science and technology. Well, it's really on atomic, molecular, and optical physics, but it's dedicated to quantum science next year. And we hope to make a little symposium partnering the Ghana Science on Quantum efforts with the German side and so on. And I'm very much looking for this. And I think in the end, it would be important also that we meet in person and not just in these rectangles or so on our video screens. However, I think we also have to consider ourselves very lucky that we can use the video conferencing now really around the world. In my view, technologically, even 10 years or maybe 12 years ago, this would have been almost not possible because the lack of bandwidth in our transmission systems and so on. So let me finish with this. I look forward to being involved in this. I really wish your school, your summer school, very good things. I think focused learning in terms of schools or so is one of the most important things in advanced scientific education in physics and so on. So I believe you are doing absolutely the right thing. And as I said, or maybe I just finish with saying that I hope you're able to really enjoy the things you're going to learn, to discuss, maybe also to controversially discuss. And I look forward to meeting some of you eventually in person and to be in contact. Thank you very much for your attention.
Thank you so much, Prof, for joining as well. And thank you for the future that holds between Ghana and Germany. And I mean, we look forward to that, the in-person session next year for the International Year of Quantum Science and Technology. Thank you so much. I mean, we've had a very major sponsor and partner as well throughout this planning and activity. And he's here with us. We would like to introduce him as well and also hear from him. He is Professor Dr. Morgan Mitchell. He is an ICREA professor at ICFO, which is the Institute of Photonic Sciences. He earned his PhD in physics from the University of California at Berkeley in 1999. Wow. Since 2004, he has led the Atomic Quantum Optics Research Group at ICFO. In addition to his research, he teaches courses on quantum optics and quantum sensing in Barcelona. His research interest lies in atmospheric and climate science, a tabletop searches for physics beyond the standard model, quantum random nuclear generation, and experimental studies of quantum non-locality. Prof. Dr. Morgan Mitchell, you're welcome.
Thank you very much for that introduction. It's a real pleasure to be here. Let me try to share my screen. Do you see my screen now?
Yes, I can see your screen.
Okay, great. So it's a great pleasure to be participating in this international school. I had the pleasure last fall of visiting KNUST and participating in a different school there that was organized by my institution, which is the Institute of Photonic Sciences, together with KNUST. And I had the pleasure of meeting Dr. Henry Martin, along with other professors at KNUST, and many very intelligent and engaged students from different countries in Africa. And so this school is going to be online, but I'm very much looking forward to having interactions with the students in this program also. I think there are some people in this photo who were at the school last fall who are also in this meeting, and so I say hello to you, and it's nice to be in the same school again. In the school, I talked about my research in quantum sensing and quantum metrology, and this was a very engaging experience. So very briefly, I think in quantum technologies, people are very familiar with quantum communications and quantum computing, and quantum sensing and metrology is maybe not so well known. So when we do quantum sensing, that is an extension of what we normally do with our eyes, with our ears, into other domains. And we can sense, for example, electric fields, magnetic fields, gravitation, acceleration, rotation, and that all comes under the topic of sensing. And when we do that in a very precise way, for example, for engineering, then we call that metrology. Metrology is the science of measurement, and these two activities are clearly very closely related. And when we do quantum sensing in metrology, that is sensing using quantum systems and metrology using quantum systems. And the reason that we use quantum systems is simply because they do a better job than the natural systems that we are given by nature. So when we improve sensing, often that means the sensitivity is better. We're able to detect smaller signals or to detect better a signal against a background. In metrology, often better means more accurate, so that if one person makes a measurement and another person in another place makes the same measurement, they will get the same answer, and we have standardization, and that's clearly very important for any application. Quantum sensing is a bit different than the better known quantum technologies. And a good example of this is a mobile phone. A mobile phone is clearly a very important technology for our age, and it is a portable computer. It has classical computing capabilities. It's clearly a communications device. It's a telephone. But what makes it a very interesting device is really its sensing capabilities. And a modern phone can have all of these different sensing capabilities. It can take photos. That means it has image sensors. It can detect your fingerprint. It, in some sense, has a sense of touch. It has a compass, which uses the magnetic field, and so on. And you see here something about quantum sensing. Like, quantum sensing is really a collection of many different tasks. It's to measure many different things, whereas computation and communications tend to be single tasks. You want a universal computer, and you want to be able to communicate any data that you can produce. And so there's a greater diversity of topics in quantum sensing. Okay. One of the topics that I work on is magnetic field detection, and I do that using atoms and sometimes with non-classical states of light. And that's a topic that has many applications. Detecting magnetic fields is important in many topics. Here's a short list of imaging. Geotechnical, which is important for mining, for detecting minerals, and up to the largest scales. Space probes use magnetic fields to learn things about other planets, and it's important for fundamental physics. And there are many technologies that have been used for that. And these are all quantum technologies: nitrogen vacancy centers in diamonds, semiconductors, Bose-Einstein condensates. There are many quantum ways to do a good job of measuring magnetic fields. And one of the things that I was talking about at the school in KNUST last fall was detecting signals that come from the brain. So this is magnetoencephalography, which is detecting magnetic signals that come from the brain. And it's a very powerful technique that is capable of detecting events in the brain. For example, if you listen to sounds which are speech, which can be understood in your language, then you get different response than if you listen to the same sounds that do not correspond to meaningful signals. And so it's a very powerful technique, but it's also very demanding. The signals are very weak, and so it can only be detected with quantum technologies. And here I was teaching about this topic, which is a forefront cutting edge topic in quantum sensing. And interestingly, one of the students asked me a question after the talk, said, could this magnetic sensing be applied to water quality monitoring, which is, of course, a very important topic for development and is a topic that was of interest to many of the students that were in the school. And I'm happy to say that we've started working on measurement of bacteria in water. So we have made now a very small atomic magnetometer that is capable of seeing a signal, a magnetic signal that is coming from bacteria in water. So this is not yet an applicable technology, but it is, I think, a very interesting interaction between the African students and my group, my research group, which gave us a new idea for something that we could study. And I hope that in this school, we will have more interactions of that kind. So I thank you very much for the invitation to participate, and I look forward to the school.
Thank you so much, Prof, for your presentation. One takeaway for me is the great diversity in this field, and we can all fit in no matter our background. It's great and to be here to listen to all these great and wonderful speeches. And I think our participants are already in that energy level where they are being quantized and energized this afternoon from Ghana. Thank you so much, Prof, once again. Before we move on to the next agenda, we would like to capture this moment with all of you all. Since we are here to explore the quantum world, let's make a group screenshots at work. So we are asking all of us to put our cameras on. Let's capture those great moments. So let's have your cameras on. Looking forward for more of us with our cameras on. Okay, so with a quantum smile, we are taking our first shot. So we are taking a second shot again. So I'm asking that maybe you didn't hear me. We would like to capture this moment. So let's have our cameras on, if you don't mind, and let's take a quantum shot one more time. Thank you. We are not done. I'm asking that we all put our cameras off. Let's all put our cameras off. All cameras off, please. All cameras off. All cameras off. All cameras off. Thank you so much. So we are taking a screenshot one more time for East Africans. So if you're coming from East Africa, we are asking that you put your camera on for us. So let's take a screenshot. East Africa, East Africa. No rep from East Africa. Okay, I think we have a rep from East Africa. Okay, so East Africa, let's take a shot. Thank you, East Africa. If you are coming from the north of Africa, let's have our camera on. North of Africa. So North Africa, if you're coming from the north of Africa. So if you are coming from the north of Africa, let's have your camera on. Let's take a snapshot. Thank you so much. You can put your camera off. Then from South Africa, South Africa, South Africa. If you're coming from the south of Africa, kindly put your camera on for us. Okay, so yeah, we have South Africa. So let's take the shot, please. Okay, kindly put your camera off for us, South Africa. So West Africa, if you're coming from the west, so West Africa. So all researchers, enthusiasts, all of us, students, West Africa, let's have our camera on for a shot. Okay, thank you, West Africa. Please kindly put your camera off. So please, Central Africa, let's have our camera on. So all others, your camera off. Then we take Central Africa, please. Central Africa. Okay, so Central Africa. I guess we are ready. Please, let's take Central Africa, please. Thank you so much, Central Africa. And thank you all for this moment as well. If you are not from Africa, you are not an African, let's put our camera on. So we have Prof. Morgan, Prof. Dita. Let's have, we are taking a snapshot as well. All right, thank you so much. That was a very quantum moments for all of us, making memories as well. Thank you. As we acknowledge the presence of our partners and collaborators, we are also very honored to have the president of One Quantum Africa with us in the person of Lauren. Lauren, you are welcome. We'd like you to say something to our audience, if you don't mind.
Hello, am I audible?
Yes, please, you are.
All right. Sorry for the background. Thank you so much, Lucas, for this amazing event and all the other organizers and partners. We are honored to have this movement in Africa, and we are glad to see so many Africans rallying forward in this quantum movement. So we look forward to having more amazing events. Thank you so much, and let's move quantum forward. Quantum for Africa.
Thank you so much, Lauren. So that's the president of One Quantum Africa, Lauren from Zimbabwe. So on that note, and transition to the next topic, we would like to invite Dr. Edem Awashi to take us through the learning management to be using the system, please. So we'll get a guided tour on that. Thank you.
So thank you so much for the opportunity. I stand on all established protocols to proceed. I'm in the person of Gaston Edem Awashi from KNUST Department of Mathematics and also the Center of E-Learning. As Director has said earlier, the university has some resources, e-resources, which we would use to support us in this school. I'm here to take us through one of the e-learning resources, which we are going to be using for the training. I would want to share my screen at this moment. Okay, so KNUST has a few e-learning resources, and one of the resources we will be using for the school is the learning management system. The URL for the learning management system for KNUST is myclass.knust.edu.gh. I'm sure by now all participants and all facilitators have a login credential which has been sent to them. So we should be able to log in at this moment. If you have successfully logged in, so this is what you see on the screen at the moment. We have the learning management system, which for us, we have the URL is myclass.knust.edu.gh. That's the URL we use. I'm sure by now all participants and all facilitators have gotten credentials that can be used as the username and the password. So once you are logged into the learning management system, the first things you will do is that you will see, so on a successful login into the system, this is the platform you will see. You will see it takes you straight onto your dashboard, and there are a few things on the dashboard. You will see the courses on which you are registered. So for this particular workshop, we are on the ELAIS-QST 2024. That's the course you will see on your dashboard. To your left, you would also see the same list of courses that are available to you. To your right, you should see some timelines if there are activities to be taken. For now, I don't have any activities in my timeline. Then users that are available online would also show immediately after that. So this side is the users that are currently online. If you need to send a message or chat with any of the users, you can do that by just clicking the messaging icon by the person's name, and then you can interact directly with the person through the platform. If you go down a little bit, we also have the calendar, so which tells you the activities that are available ahead of you in a few days. So you see, I have an activity on my schedule for the 19th and the 20th, and then I have some upcoming events, which would all show on the platform that you have. If I need to access the course, then what I would do is to go and look for the course on my dashboard. If I have accessed the course before, then the course will show in my recent courses. Otherwise, it would be in the course overview. Courses I haven't accessed recently would not show in the recent courses. So if the course is in the recent courses, then I can click directly on it from there. Otherwise, I go to the course overview and click directly on it from there. So I'll click on my course. When I click on my course, I will see activities that are ahead of me on this particular course. For now, the activities are yet to begin, so we won't see too many activities on the platform. But once the activities begin, lecture materials will be put on the platform. Announcements would be shared on the platform. Assignments, quizzes would be done through the platform, and all other activities would be done on the same platform. But last but not the least, if you see the top of the screen, to the right of the screen, you should see your name. If you have successfully logged in, then you should see your name on the right side, top corner of the screen. There is a drop down arrow. Once you drop down the arrow, the first icon would take you back to the dashboard. So if I click on that, I should automatically go back to the dashboard. Aside that, I can edit my profile and check my grades. If I have done some activities and those activities have been scored, then I can go in there and then check the grades. I can message people from there, and then I can log out of the system from there. So I can change for instance, if there is a mistake with my name on the platform, I can just edit my profile and then update the name. Or I can, if I want to add a picture, I haven't added my picture yet. And as the university, to give you all the necessary support and help each individual will need to successfully complete the school. Thank you very much.
Thank you.
Thank you so much, Doc. Thank you for the guidance. So the team will be available. You can reach to us through the email we've been sending messages through. You can also reach to us on WhatsApp or make use of the platform as well to ask questions and make comments for that. So thank you so much, Doc.
But it's fantastic to be here anyway, like, and to be given this opportunity. And people around me, they know that from day one I've been saying that I want to move with quantum in pictures to Africa. Why would I want to do that? Because we are in the West, here in the West, we are plagued by 2,500 years of scientific history, which is actually a constraint to some extent. We have started to think in a very particular way, a very reductionistic way, which is like that we try to understand things, how they are made up. And I believe that quantum mechanics is telling us that we need to understand things in a manner, how they relate to each other. How do I relate to you? How do I relate to my environment here? That's basically what these pictures we're going to teach quantum in is going to do. So I wrote this book with Stefano Goggioso, Quantum in Pictures, which was a follow-up on a book with Alex Kissinger, Picture and Quantum Processes, which is presenting quantum mechanics entirely in diagrammatic terms. This is very rigorous mathematics. This is completely equivalent to the Hilbert space form, to the extent that whatever equation you can prove using linear algebra and all of that, you can actually prove using these pictures too. But it's different. Why is it different? Because you can teach it to teenagers. You can teach it to, I don't know how young we can go with this. But so we only have done experiments till the age of 15. And the remarkable thing is the younger the students are, the better they do, which is incredible feat. And this, I mean, the way I think about this is you have less to unlearn if you know less. And it's much easier to go into this new way of thinking if you know less. And like going back to the story, so I believe the less Western scientific culture you have, probably the better you're prepared to understand new ideas. So that's why I effectively want to take these two different continents. I'm looking so much forward to the course we are going to do. I'm thanking everybody who helped like a lot, like especially Katrina, did a lot of work for preparing this. So yeah, see you soon.
If you have questions to our participants, you can raise your hand using the raise hand reaction, or you can ask your question in the chat, please. So we take questions now. If you have direct questions, in asking your questions, you can address the one you want to answer your question for you, please. Question from our participants or in the chat, please. You can also unmute yourself and ask your question. It looks there's no interference here. We are all in a very great entangled state, and we are coexisting among ourselves, hoping to achieve a new technology, I guess. Okay, so we have a question. This is to Dr. Martin, I guess. What's the next step after the course? Are there any opportunities for joining researchers outside Ghana?
Well, thank you very much for the question. So just as the roadmap indicates, the concepts for the school is to come up with trained Africans. And so as part of the school, there will be projects from our facilitators. This then is to bring in collaborations with our partners outside Ghana and Africa as well. And so it basically lies with the hard work of the participants, how you conduct the project, which is a small project to say. And as you listen from Mitchell, there was a question from an earlier school which brought up a project they are conducting now. And so your hard work from each of the projects would bring in the collaboration and also further research work. And as I also showed from the roadmap, there is that idea to have an in-person one next year, which also the German Physical Society also mentioned. And so there's more for us, but it lies in our hard work and our studies. Thank you. I hope I've answered the question.
Thank you so much, Dr. Martin. Yes, there'll be certificates issued by the institution KNUST, so you are going to get a certificate for that. We have a question. How detailed is the course going to be? To what level of fundamental concepts of quantum science might we probe?
I will answer that. I'll say that the participants should wait and then for everything to be explored. You are coming to the school that is expected to give you not necessarily foundation, but whet your appetite to develop interest in areas of quantum technology. So then just be patient and everything more things will come to you. Thank you.
Thank you so much, Prof. Yes, there will be mentorship. So we are talking about continuity and sustainability as well. So this school doesn't just end online. So from Dr. Martin, he did mention also about in-person next year, God willing. So please, there is more to come. You are not going to be left alone after this training, because you get to do projects with other researchers from outside Ghana as well. Thank you. So I'll give room for Emmanuel Obri Efriye. Emmanuel, you can unmute yourself and ask your question, please. Emmanuel, you have your hand raised. Okay, so if you have a challenge with the e-learning platform, kindly send us an email or reply to the email that was sent out to you, and we will get it worked on, please, if you have a challenge with that. And most of the topics, most of the courses are yet to be loaded as well. Yes, please.
My question is, some of us, we are experiencing unstable, network. And so are we going to get a recorded version of the program?
All right, thank you for your question. In as much as we'll be recording sessions for lectures, we encourage that your presence as well is very important to us. It will all form part of you getting a certificate. So we wouldn't want facilitators to come and meet no audience, because there will be a recorded version of the lecture. So please, we are urging and encouraging all of us. Since we will have the schedule, we may need to plan ahead as well as participants to getting good internet connection to actually join the main class, please. So please, participants, we are urging all of you to do that. We are here to upload courses, documents, and materials on the e-learning site. So kindly be patient with us. Please, what laptop or computer system requirements are needed for the practicals? Dr. Martin, would you like to answer, or I should continue?
Well, it's I think we're just going to do some basics of Python, and so it's not any high spec, and so with the Python, and then we hook up to some of the quantum computers as well. So it's not any high spec PC that you need, but all specifications will be placed in the e-learning when needed. In any case, when the facilitator need more, we'll let you know.
All right, please. Thank you so much. What are the job opportunities for one studying quantum technology apart from the research works that I know? Rolf, would you like to comment on that?
Yeah, so I think that the sixth person who spoke, that was Professor Morgan, has given you,
yes.
one, he talked to you about the applications of the quantum sensing, and he used a mobile phone as one. In fact, quantum science is what has revolutionized our world. And possibly you and I are able to even see ourselves, apart from the bandwidth and other things they talked about, quantum science has played a role. So in general, when we talk about work, there are a lot of application. You may not directly have application apart from going to the lab to explore, to do other things. Companies can also employ you as a scientist that really understand how to use quantum. So he has shared that, and I believe that more lectures are going to highlight some of areas that will interest you to develop in. I don't know whether I want to move on and end the session. Will you want me to continue and end the session? Thank you very much.
Yes,
starting with Professor Mrs. Abandam. Thank you, Madam, for still motivating the younger ones to continue studying science, in particular quantum physics and its application. Madam, let us aware that it's important to bring out some innovation, practically oriented labs that will really apply quantum technologies. She also talks about the fact that she lamented about the decreasing number of people who are studying physics, and still hoping that more people study physics. We hope that will continue. This is as a result of mentoring people in mentoring, and then the what people societies. When you tell people you are studying physics, you are seen as somebody who is abstract and not even thinking or thinking. People see physics still as a very subject that cannot be studied. But we want to say here that physics is studied by human beings, and all technologies that we see today drive around physics. Madam emphasized that, and he asked that we should create quantum technology hub as well. Also, she touched on mentorship and capacity building. Here, I want to emphasize that we need a critical mass of physicists. I can tell you, if you understand quantum physics very well, understand its application, you move in any area of physics. All areas of physics strive on physics, on quantum. I come from the field of atmospheric physics, and I can tell you that almost all sensors that we have in the space taking measurements, most of them that are very efficient, use quantum effect or quantum principles. Those of them that can do the best sensing information, they are actually quantum sensors. So it's very critical. The e-learning director came on, responded. He tried to give us all the things that the KNUST have. I can tell you KNUST ES Center is one of, it's a top-notch center. It's a center that really have a lot to offer. And what he said was just, a little that he has mentioned, but there's still more they can offer. And that was later on explained by another person. And there's still more you have not explored. So when time comes, they also have a dedicated staff that are willing to support this program. I am happy as a provost of College of Science that my college is hosting this particular program. In particular, my own second department, Department of Physics, is the one hosting this particular program. Just to move on, Dr. Martins tried to wipe our appetite, bring in the basis. I was so impressed with his presentation, trying to look at the basis of the how quantum started. They talked about the history, and then he mentioned some key people that really worked in quantum mechanics. And then he also motivated us look at the applications of quantum mechanics and look at more work. He indicated that we stood on the shoulders of giants, and so it means standing on the shoulders. That is why we can see a lot of the technology. That is all that Martin is trying to see. The lots of technologies that we see today, people have really worked so hard, and their knowledge has been applied later into technology, and that is what we see today. And there is also going to be the next world. If any world exists, the fifth world is going to come. No other person will change that world by the quantum technology. I can bet all of you that that is going to be the key. Then Professor Dieter Mechiste, he looked at some initiatives and talked about the International Year of Quantum Physics, which is a program that will take place next year, and that signifies 100 years celebration of quantum mechanics. And I think it's exciting, and I would like to be part of that, those Ghanaians that will have opportunity to benefit from this program. As physicists, I think that without quantum, we do little. And so I believe that that's going to be exciting. And I believe our other African partners are also looking forward to be part of this very celebration. Then we moved on. We had Professor Morgan trying to look at the application of quantum science, and he talked about quantum sensing. He talked about how quantum can be used to provide precise measurement. As I mentioned, today in the atmosphere, most of our measurement devices used to be, if you talk of precision in measurement, quantum devices are the best, because they measure in the nanoseconds, or some are, some are even more accurate than that. They are really, really precise. And he emphasized on, talked about how that has been used into medical diagnostics, and then how quantum has been used to study the brains and how the responses of sound and among others. He really language interpretation and many others he touched on. Then we have our president of the quantum physics community, which I would like to be a member. So if you can share a membership card to me, I will join. And Lauren Chichi, if I got your name right, I don't know, it's doctor or professor, I don't know, but just to say that we thank you for initiating this in African continent, and I want to be a member. Dr. Edem Washi also emphasized on e-learning platform, the system, and provided how KNUST e-learning platform work. We're looking forward that participants will be able to efficiently use the e-learning platform. In general, I want to end that by saying that, which Dr. Martin started answering some of the questions. The aim of this program is to build capacity, develop critical minds. You know, if you remember, in Einstein, since we are in a quantum world, we talk about energy, which is mc squared. And then M stands for a mass. That mass must be a critical. If it's not critical, you can imagine the speed of light, which is c squared. So if you have a high speed of light, and you don't have a mass, a critical mass, that completely the mass cannot have effect in with the relation. So we need a critical mass, and Africa must build that critical mass in order for us to make impact in quantum technology and quantum physics. Thank you all for listening. Thank you.
Thank you so much, Prof. All too soon. We are concluding. As we conclude this session, let's carry with us the principles of quantum mechanics, embracing superposition by keeping our minds to multiple possibilities, fostering entanglement by connecting deeply with one another, and leveraging constructive interference to amplify our collaborative efforts, and also navigating the uncertainties of the future with curiosity and innovation. So please, we would like to take the votes of thanks from Henry Kwashi to close the session, please.
Okay, thank you, Dorcas. So on behalf of the entire team, I would like to express our heartfelt gratitude to everyone involved in making this program a success. To our chairman, the provost of the College of Science, Prof. Leonard Amekuji, thank you for your leadership and guidance. So a special thanks also go to our distinguished speakers, Professor Abandam, Prof. Eric Asante, and Prof. Inin, the HOD, the representative of the HOD. We also are deeply honored by the contributions of our guest speakers, Prof. Dieter Mascheda from the German Physical Society, Prof. Dr. Morgan Mitchell, and then Lorraine Majiri from the One Africa. So to our organizers and then support staff from the physics department, e-learning and across the board, we appreciate your tireless efforts, attention to detail and dedication to ensuring a smooth and enjoyable experience for all participants. So to our collaborators and partners, we value your support, guidance, and collaboration. Your involvement has been instrumental in shaping this program and its outcomes. And also to our participants, including those joining us from across Africa, we thank you for your engagement and then enthusiasm and commitment to the learning. Your presence has made this program a vibrant and dynamic community of scholars, researchers, and learners. May the connections made, ideas shared, and knowledge gained during this program continue to inspire and empower us to make positive impact in our lives and the world around us. Thank you all once again for your contributions to this program. May we continue to grow, learn, and thrive together. Thank you.
Thank you so much. Thank you all. We'll meet again. Thank you.
Bye.
Bye.